Reaction with carboxylic acid. Reaction of what? Alcohols. Okay, please write. Alcohols react with monocarboxylic acid, in the presence of concentrated H2SO4, in the presence of concentrated H2SO4, or we can use dry HCl to form esters. So please see, we have R, C double bond O, and we have OH. And from alcohols, what do we have? HO R dash. Okay. So this hydrogen, it gets removed from the alcohol. OH gets removed from the carboxylic acid. And this leads to the formation of water molecule is being removed. And you have R, C double bond O. We have OR dash. Okay, so this is an ester. Can write some more examples. OH plus CH3OH. So see, from here OH will be removed, from here hydrogen will be removed, and you will be getting double bond O, OCH3. Okay, plus water is also there. Both of this is happening in the presence of an acid. Okay. For example, you have something like this also. From here, OH will be removed. From here, hydrogen will be removed, and you will be getting double bond O, and then this will be connected to O. Try it more properly. Done, everyone? Yes or no? Please tell me. All of you wrote this? Fatima, Samiha, Razan, Wafia.
Yes, sir.
Yes, done. Okay. Please write next. The above reaction is also called esterification reaction. Next point. Okay, please see. Presence of bulky group. Yeah. Rehan, tell
Can
me.
you scroll up, sir?
Yeah, sure. Presence of bulky group on either of reactant that is alcohol or carboxylic acid reduces the rate of reaction. Okay, that means if I talk about the order of alcohols, then the alcohol with the least number of carbon atom, the CH3OH, will be fastest, followed by when you have 2 carbon atoms, followed by when you have 3 carbon atoms. Okay, so if you increase the number of carbon atoms, then the rate of reaction is going to be slower. Similarly, I can also write 1 degree alcohol is fastest, followed by 2 degree alcohol, and followed by 3 degree alcohol. Right, next order of Ca. Ca is carboxylic acid. Okay, Ca is carboxylic acid. So in carboxylic acid, we'll have HCOOH, which is smallest, to be faster, followed by CH3COH. Okay, which will be followed by CH3 whole twice CHCOOH and so on. Okay, so if you have more number of carbon atoms and if you have bulky group around the carboxylic acid, then it will lower the rate of reaction. It will reduce the speed of reaction. Done, everyone? Yes or no, please tell me. Okay, लिखिए जल्दी से बताइए फिर when you're done. Ahmed is done. What about others? Rehan, done?
Done, sir.
Done. Right, next, reaction with acyl chloride or acid anhydride. Reaction with acid chloride, right, and acid anhydride. Okay, and this you're going to write when alcohols are treated with acyl chloride or acid anhydride, in the presence of base, such as pyridine, then the hydrogen atom of OH group hydrogen atom of OH group is replaced by RCOO group, or rather RCO group. Also, what is this RCO group? Okay, right here, RCO group.
Done, sir.
Done, everyone? Okay, right, next. Here's 3 C double bond O, Cl. This is ethanol chloride. Okay, so this is an example of acid chloride. It is said acid chloride because this chloride is being made from carboxylic acid. Okay, that's why it is known as acid chloride. But right now, this is what ethanol chloride. Ethanol chloride. Thus, we will react a alcohol HOCH3. And you should remember that we are learning the cleavage of OH bond. So we'll break this bond and यहाँ से chlorine निकल जाएगा, right? And you are going to get CH3, C double bond O, and then OCH3 is as it is. So this is from alcohol, and this is from the acid chloride. Can all of you see that? Yes or no? Please tell me. Plus, we are going to get HCl, and we are using pyridine here. Why is pyridine used? Pyridine is a base, HCl is an acid. So pyridine is going to consume HCl, and if the product is getting consumed, then the reaction will shift in the rightward direction. Okay, so we'll write that point also. But all of you understood this? Yes or no? Please tell me this reaction. OH bond ka cleavage. Okay, right. Next. Now we are going to look at an example of. See, there are two things that we are going to look at. Okay, first of all, this is acid chloride, and then acid anhydride. So please see what is acid anhydride. Yeah, acid anhydride पे देखिए CH3 C double bond O, and then we are going to have oxygen only. See, we have not written hydrogen. That is why it is what anhydride. And in place of hydrogen, you already will have carbon double bond O CH3. So this entity, this whole entity is known as what? Acid anhydride. Plus we are going to react. Plus we are going to react with this alcohol. We are going to react what? Alcohol. So we'll have CH3 and OH. CH3 and OH. Okay. Now see here what happens. This hydrogen will be broken, and this hydrogen will go away with this complete thing. Okay. And you're going to get from this hydrogen is going away. So you'll get CH3, C double bond O, OH. Plus what you're going to get, plus you're going to get, this is going to get bonded to this oxygen atom. So you are going to get CH3, C double bond O, and OCH3. Again, this is from your alcohol, and this is from your acid anhydride. Can all of you see that? Yes or no? Please tell me.
Yes, sir.
Okay. Is everyone done? लिख के बताइए if you're done.
Done, sir.
Done, everyone? Is there anyone who is still writing? Yes, Wafia, Fatima, done?
Yes, sir.
Yes, sir.
Yes, okay. Right, next, some remarks. Please write this reaction is known as acetylation, okay? As it introduces acetyl group. Right, next. This is a very important point. The reaction is done in the presence of pyridine. In the presence of what? In the presence of pyridine. What does pyridine do? Which neutralizes the HCl, and equilibrium is shifted. Right. Equilibrium shifts in rightward direction. Forward direction. Phenols also show similar reaction with carboxylic acid. Oh, carboxylic acid, acid chloride, and acid anhydride. Okay. अच्छा, एक सवाल लिखिए. You will do this in your homework, okay? Write the reaction for formation of aspirin. Okay. You will find this in your textbook. It is there in your NCERT textbook. You will try to find it out. Okay. Similar reaction, and do this reaction with certain kind of phenol. Is everyone done? Yes or no? Please tell me.
Yes, sir.
Okay, right. Next, reactions involving B part now. We have already looked at the reactions involving cleavage of OH bond. Right, the B part. Reactions involving cleavage of OH bond. Reactions involving cleavage of OH bond. OH bond लिख दिया हमने. Wait a second guys. OH bond तो पढ़ लिया ना. Please write. COH bond. Okay, this CO bond we have to break. How can we break the CO bond more easily? If we have high polarity in the CO bond, then it is easier to break. Please write next. Higher the polarity of CO bond, easier it is to break. Easier it is to break the bond. है ना? Break the bond. Right next. As the number of alkyl group increases on alpha carbon, increases on alpha carbon of what? Alpha carbon of alcohol. Easier it gets to break the bond. देखिए, so reactivity is going to be what? 3 degree will be most reactive, 2 degree will be the next reactive, 1 degree will be least reactive, and the very least reactive will be CH3OH. Write this down, then I will explain why 3 degree is most reactive, then 2 degree, and then 1 degree.
Done, sir.
Write it down, let me know when you're done. Okay, now see here. Let's suppose we have a simple carbon atom like this, and we have OH. Okay, CO bond like this. We have CO bond like this. Now, please see here, if this CO bond is going to give it electron, this oxygen is going to get delta negative, and this carbon is going to get delta positive. Okay. Now, higher the delta negative, higher is also the delta positive. Now, look here, if you have carbon atom which is connected to further one more carbon atom, an oxygen. So this alkyl group is doing what? This alkyl group is going to give the electron, and this carbon atom also is going to give the electron. So this will be what? Having even higher delta negative, and this delta positive will also be higher. That means if you have high delta negative, high delta positive, it is going to be making this bond more polar. Let's suppose we have one more carbon atom attached to it. So this is my alpha carbon. This alpha carbon has one more carbon attached to it. It's one carbon, another carbon. Now both of these carbons are giving electron, and this carbon is giving electron towards the oxygen atom. This delta negative is going to increase furthermore, and that is why this delta positive is also going to increase furthermore. Okay, so this is why the reactivity of 3 degree is fastest, then 2 degree, and then 1 degree. All of you got this point? Yes or no? Please tell me.
Yes, sir.
Why the
Yes, sir.
reactivity of 3 degree? Okay. Right, next. First reaction is reaction with hydrogen halides. Okay, if you remember, we have already done this particular reaction in the chapter haloalkane and halorine. Okay, please write alcohols react with hydrogen halide to form haloalkane. To form haloalkane. We have already seen this in the preparation of haloalkane. Now, reactivity of the hydrogen halide. Which hydrogen halide will be the most reactive? So hydrogen iodide is going to be most reactive because it has a very long bond, which is easy to break, followed by HBr, and then followed by HCl. Right, next, reactivity of alcohols. So we have already seen what bond is going to break here. The bond between the CO bond is going to break, right? CO bond is going to break. We have already seen what will be the reactivity. 3 degree is most reactive, followed by 2 degree, followed by 1 degree, and then followed by CH3OH. The simple reaction is going to be ROH plus HX is going to give you Rx plus H2O. Let me know when once you're done, okay?
Done, sir.
Done? Great. Now, write some remarks. See, the HCl is having least reactivity, and 1 and 2 degree are also having low reactivity. And due to this, we need some kind of catalyst for this reaction to happen. Please write, due to lower reactivity of due to lower reactivity of 2 degree and 1 degree alcohols with HCl, catalyst anhydrous ZnCl2. Anhydrous ZnCl2 is used. Okay, right, next point. The reagent anhydrous ZnCl2 plus HCl is known as what? Tell me, guys. Is known as dash. What is this reagent called? Okay, so this reagent, and the same reagent is used for the distinction between 1 degree, 2 degree and 3 degree alcohols. जी बताइए, what is the name of this reagent?
Lucas
किसी
reagent.
को? Yeah, who said this answer?
Samia.
Samia, very good, Samia. This is known as Lucas reagent. Okay, Lucas reagent or Lucas reagent. Sometimes when I ask students who said this answer, do you know what they say? They say me. Sir, I said the answer. I said the answer. It's like if someone is knocking at your door, you call out, "Kaun hai?" Hum hai. Do you have those people there also in Middle East? But I think in Middle East you will have those क्या बोलते हैं उसको? जिससे you can see who is outside. There are some holes in the door, na?
Door
Does it
hole.
have some name?
Door hole, sir.
इसको door hole ही बोलते हैं. अच्छा. No creativity there. Okay, fine. Door hole. We will have some door holes there. But still, if you don't know someone, then you will ask, है ना? कौन हो भाई? Done everyone? Yes or no? Please tell me. This
Yes.
Lucas region बहुत ही
Yes,
गंदा
sir.
लिखा हमने यहाँ पे, इसको ठीक से लिख लीजिए प्लीज. Lucas region. Okay. Now, please write next. See, देखिए alcohol, these are soluble in water. Okay, alcohols are what? Soluble in water. Lucas reagent is also soluble in water. So if you have a container in which you have alcohol, तो आपको पता ही नहीं रहेगा कैसा alcohol है. दूसरे कंटेनर में क्या है आपके पास? Lucas reagent है. This is also soluble in water. But when you are going to mix both of these things, you are going to get what? Rx, right? Rx, and especially not Rx, you are going to get RCl, right? And RCl is what? It is having white PPT, or rather not white PPT exactly, but there is turbidity. White turbidity is there. Okay. Do you know what is turbidity? हमने बताया था नहीं बताया था? Remember Fatima, Sarah, you guys remember turbidity? No. Yes, Sarah, tell me.
No.
No, you don't remember turbidity. Wait a second, let me show. Can all of you see now? Okay, this is your clean water. This is your clean water, okay? And this is the turbidity. So this kind of turbidity is formed when you are going to mix alcohol and Lucas reagent. Okay, so Lucas reagent, first of all, it is going to give you that whether you have alcohol or not. If you have alcohol, then it is going to give you turbidity. Now, how is it going to distinguish between 1 degree, 2 degree, and 3 degree alcohol? So please write, if you have 1 degree alcohol, and then you add Lucas reagent to it, what I'm going to add? I'm going to add Lucas reagent. Then it is going to give turbidity with some heat. If you give heat, then it is going to give you turbidity. Or you will write no reaction at room temperature. ठीक है? Heat करने पे ही you will get turbidity. So this requires time. 2 degree alcohol at room temperature only, it is going to give you turbidity, but this requires time. Lucas reagent is going to give you turbidity, but after 5-10 minutes. 3 degree alcohol, it doesn't even require the Lucas reagent completely. If you only give HCl, then also this reaction can happen. But we generally give Lucas reagent to be consistent. It is going to give you turbidity immediately. Quickly you can write. All of it done? Yes or no? Please tell me. Done, guys?
Done, sir.
Done. अब देखिए एक इंपॉर्टेंट पॉइंट है जो आपको को याद रखना है. 1 degree alcohol reacts with HX via SN2. Okay, so there is no formation of carbocation. Simply what they do, they react via SN2. That means, for example, you have OH like this, plus I am reacting HI. So this iodine negative is going to attack onto this carbon atom. See, iodine will be delta negative. Oxygen is bonded to carbon atom. This will be delta positive. So this iodine is going to attack onto this carbon atom. Okay. But I mean, first of all, a different reaction happens. पहला reaction step होता है. चलो, आपको दिखाई देता है. Write this reaction OH plus HI, giving you OH plus HI. It is going to give you iodine like this. Okay. Now step 1 is going to be the alcohol gets protonated first. You have H plus from HI. So oxygen atom attacks onto this H plus, leads to the formation of. As soon as this forms, this will have a positive charge here. There is iodine negative waiting to attack onto this carbon atom. It attacks on the carbon atom and it leaves. And hence we get water molecule. As you can see, ये दो step में हो रहा है, but first step is protonation of alcohol. But look at the step 2. There are two things happening simultaneously. The nucleophile is attacking also, and the leaving group is leaving also in single step. So this is what? This is SN2 reaction. Okay, it happens via SN2. We'll write next 2 and 3 degree alcohols. Alcohols react with HX via SN1, and hence quite often they give rearranged product. Write this much down. Let me know when you're done. Then we are going to do a very good question from NCERT itself, and very important question also. Okay. Is everyone done? If not, please tell me. Okay. Let me know once you are done, guys. Done. Right, next. Again, this is very important question. Okay, it's a very important question. Please see. We have a we have a reactant, that is alcohol, with a structure like this: CH3 carbon with one hydrogen, CH3, CH, CH3, and this is having OH. Now, what we expect in this reaction to happen, we expect our product to be, if I'm going to react this with HBr, CH3, CH, CH3, CH, CH3, and Br will be placed here. But we don't get this product. The product that we get is, please write, CH3 carbon, CH, this is also CH3, and now it gets two CH3 molecules, one CH3 here. No, this gets two hydrogen. 1, 2, 3, 4 carbons. Yeah, carbons number are same, and we get the Br group here. Okay. This is the actual product. This was the expected product. Now we need to see what is happening here. We need to see what is happening here. Now, please see, guys, don't write anything. Please look, and then we are going to understand what is happening here. So I'm going to write the bond line structure for this. We have 1, 2, 3, 4 carbon atoms. So we have put 4 carbon atoms like this. The second carbon atom is having a CH3 group here. And the third carbon atom, or rather I should say the third carbon atom is having CH3 and the second carbon atom is having OH. Now, in the presence of HBr, it is first of all going to look at H plus ion. We'll have H plus ion here. The oxygen molecule is going to attack onto this H plus because electron source to electron sink. Then next we are going to get the CH3 will be as it is. This will be O, H and another H with a positive charge on the oxygen atom. Now the next thing, as you can see, since this is what 2 degree, this is 2 degree, this oxygen can leave with the electron and neutralize itself, leading to the formation of what? Leading to the formation of a carbocation, which will be something like this. Positive charge and CH3. Okay, and CH3. Now, all of you go to the haloalkane halorine part, those who did haloalkane halorine with me, and I also discussed rearrangement of carbocations, right? I also made a big diagram like this, a flow chart. If you have this, then this will happen. If you have this, then this will happen. If you have this, then this will happen, right? Can all of you go there and tell me what is going to shift? Hydride shift hoga ya methyl shift hoga ya kuch nahi hoga, right? You have 3 cases, or also there is one more case of ring expansion, but obviously there is no ring here, so there is no question of ring expansion here. Can all of you go and please let me know whether we are going to have a hydride shift or a methyl shift in this case? याद है कि नहीं याद है आप लोग को? सारा, फातिमा, वाफिया, tell me guys, you remember this? We have done it now. Yes, tell me.
Yes, sir.
Yes, na? Please just find it in your notebook. What is going to happen? Will there be hydride shift, methyl shift? दो ही केस है बस आपके पास, तो हाइड्राइड शिफ्ट होगा या मिथाइल शिफ्ट होगा? Let me know once you find it. या किसी को नहीं मिला? फातिमा, सारा, रजान? It was at the end of SN1 and SN2, na, when we almost ended the discussion on SN1 and SN2.
Sir, hydride shift.
रजान आपको मिल गया? What about others? किसी और को मिला है शायद? Okay, Wafia also got it? Okay, yeah, that is correct. Hydride shift, okay. अच्छा बताइए कौन से कार्बन से हाइड्रोजन निकलेगा? 1, wait a second. 1, 2, 3 और 4. From where it will shift to where? Tell me guys. कहाँ से कहाँ shift होगा? This is 3. This is 4. Tell me. You will shift the hydride from which carbon to which carbon? Samia, have you done this rearrangement of carbocation?
No, sir.
This question is in NCERT only, okay? And if you, I think this is the last question of alcohol, phenols and ethers. NCERT exercise, and if you look at the hint, they have also given a hint that hydride shift will take place. Okay, so ऐसा मत समझिएगा कि सिलेबस से बाहर का है, NCERT का डायरेक्ट क्वेश्चन है. Schools में generally they skip this things of hydride shift and all, but boards में आ सकता है. जी बताइए कौन सा कहाँ से कहाँ शिफ्ट करेगा? What happened? Yes, Razan, what do you think? 1, 2, 3, 4 में से कहाँ शिफ्ट करेगा? 3 to 2 से कहाँ शिफ्ट करेगा? 2 to 3 शिफ्ट करेगा. Okay. See, we have a hydrogen here, which is almost in the same plane to that positive charge. It is going to shift like this in the positive charge. And what is going to happen? This is going to get a hydrogen. That means the positive charge will be neutralized. The CS3 is here. Now this carbon atom is going to get a positive charge because it gave one of the hydrogen. That means hydride. Not only hydrogen, hydride. Hydride means H negative. That means it gave hydrogen with the electrons. So if it gave hydrogen with the electron, it will get a positive charge. And then now the Br negative is going to come. And it is going to attack onto this carbon atom, leading to the formation of, this will be obviously once, not reversible. Br and CS3. Okay, so this is the product that is formed here. Please write this mechanism down. Let me know once you're done. आप लोग में से किसी ने हमसे कुछ सवाल किया था क्या कभी व्हाट्सएप में? हमने रिप्लाई नहीं किया हो. There was one kid who messaged me, like it was very late, but I told her that I will reply later, but हम फिर